Hi folks, Harper Dada here. Let's do the Leetcode 328 today. I was asked this question in a interview recently, in fact, like couple of weeks ago, and this guy who was a complete bozo had the audacity to ask me this question, and you couldn't even hear his. You couldn't even understand what he was trying to say most of the time. His accent was so heavy, Asian, but it is what it is. And then I guess we have to live with these kind of characters in the Silicon Valley. So anyway, let's try to give it a shot. So we'll see how we can solve it. And then let us read the problem first. Given a singly linked list, group all odd nodes together followed by the even nodes. Please note here we are talking about the node number and not the value in the nodes. You should try to do it in place. The program should run in O1 space complexity and O nodes time complexity. So what he's saying is, when he says O1 space complexity, he's saying do not try to do any extra allocation. That means no mallocs, no dynamic memory allocation, if that is what you want to like to say, because in C++ you use new operator, and then C you use malloc. And he's saying the time complexity should be ON. So I guess depending upon how many nodes you have in the list, should only take that much time, not n square or anything like that. And the most important thing I would say here is to note that, please note that here we are talking about the node number and not the value in the nodes. So basically, this is not about looking at node dot data or node pointer operator data or whatever. It is just, okay, this is the first, this is the second, this is the third. Like for example, here in this case, now it so happens that the even and odd actually happen to be named that way, but you see here 1 2 3, so it's 1 3 5 and 2 4 null. That's cool. Now let's look at this input 2 1 3. So as you can see, 2 3, so this basically connect 2 with 3, 1 with 5. So that is this. So the first one with the third one, second one with the fourth one, do not care about what's actually inside them. They may be having even data, odd data, who knows. They may be having a wide star pointer, opaque data, whatever it is. So the relative order inside both the even and odd groups should remain as it was in the input. The first node is considered odd, the second node even, and so on. The length of the linked list is between 0 and 10 raised to the power 4. I wonder what is the implications of this. I mean, why do they even give us? I mean, does it matter? The solution doesn't care if you have a node whose length is greater than 4, 10 raised to the power 4. So that is like saying, hey, I will not give you a linked list which have more than 10,000 nodes. Fine. I mean, this solution should actually work for million nodes as well. So here we are, and we would try to understand how things are going here by seeing if we can solve this problem in the constraints that are given to us. So what I feel is we need to definitely, if you are given these kind of problems, always start by checking for the input, because it's a pointer. Or even if it was Python, always check if the node you're given is valid. In C, you would do it like this. You may say either if had this is means basically checking for the comparison operator equal to null, then basically return, right? And the C guys who consider themselves as the experts, they tend to write this as more like this: if not had, then return. Maybe that's if that's what if you prefer, then let's have it that way. So if not had, then return. We can probably write a comment here saying that if had is null, return. Now, the next thing we do is we start by having uh, if you guys want to save on typing, then one thing we can do is we can basically make a type def here. We can say type def struct list node as node, and that kind of help us because I can simply just say node star odd. So we start having a pointer odd pointing at head and a pointer even pointing at head next. Now you see, one thing we know at this point is that head was not null, otherwise we would have returned right here. So if we are given an empty list, we bail out at line number 13. Else we proceed. So we know that odd at least is not null at this point, but even could be, right? Because you could be given a list with just one node in it. So in that case, other approaches, another I would say thing is that now that even we have the first element of the even list, and we want to put all the odd elements first and then all the even elements, we probably need a variable to store this head, even head, if that's what you want to call it. So maybe we should have a variable like even head that basically stores the head of the even list, and that's going to be in the beginning this. Now what we should do is while odd or even, we should continue, right? We should, as long as odd and even. So you see, we would be starting odd here, even here. Now odd will go skip one, basically the even node next to it, and point to the next odd, and even would do the same. So as long as odd and even are valid pointers, we are in shape. But there are two possibilities. One possibility is that the list has even number of odds. So if you continue to do that, you would see just before they start running into the null pointer, odd will be pointing at for example, let's take this list. I wonder how many this has. 2 4. This also has odd number of, this one has also odd number of. But suppose you had a list like this: 1 2 3 4 5 and 6. So you start pointing odd here, even here, then odd goes to 3, even goes to 4, then odd goes to 5, and even goes to 6. So in the end you will see that odd is pointing, if the list has even number of elements, then just before the last element we would see that the odd is pointing, the odd and even, they're basically pointing next to each other, and basically evens next will be null. If evens next is null, we know that the list has even number of elements. But if odds next is null, that means we know, imagine if we had one more here, then we know that the list has odd number of elements. So we may have to take care of these cases But right now let's just proceed. So while odd or even, what do? We we know that the odd must, in the very beginning, odd can never be null, because we already checked for the even could be null. But that doesn't matter. We still come inside, and in the equilibrium case. And why equilibrium? I mean, when everything is fine, you're in the middle of the list, what do we need to do? Ideally we should do something like odd next equal to even next, right? Because now you want to basically skip the the node next to odd. Basically you want to point odd to the next odd, which will be the element immediately the after the element which is next to it, which is even. So that is the idea here, and then odd will move to odd next. So this way we have basically pretty much made odd to point to the element uh, immediately after its next element, right? Similarly, in the once the odd is starting to point, suppose let's just take this case. So now odd is pointing at 3, but you see the even is still pointing at 2. So even has to point at 4. How can we do that? So we say even equal to even next, that means in this case 2's next should be pointing at odd's next now, because now the new odd is 3. So even next should be pointing at odd's next, and even equal to even next. So even, so basically this way, ideally in the equilibrium case where you're in the middle of the processing, you would be you would see that that's how they are basically they should be moving. But we have to take care of the boundary conditions. Like for example, if the if you have, for example, if even next is null, now what happens? Because we know that the even is the element that is kind of, if you think in the very beginning, is the successor, not the first element, right? Even is kind of successor. We start by having odd pointing at the head and even at the next. So if so, the possibility that even would be null should be taken into account first before we should see if odd should be taken into the null. So if even next, if not even next, we could have written either that, or we could write this. If even next equal to null, then what do we need to do? In this case, let's just take this case. If this element after this is null, if odd is pointing at 5, even is pointing at 6, and even next is null, what happens now? We should do the so the even list is done, but the odd list is, you see the odd next at this point is still pointing here. It should be pointing at the, so what we should do is we should have odd next point at the head of the even list that we saved. So all we need to do in this case is odd next pointing at the head of the even list. So that is even head. So if even next is null, odd next points at the even head, and we can pretty much return head and we are done, because we haven't changed the head at any point anyway. So that is one case. Now if that is not the case, then we go ahead and dereference, or basically make odd point to the evens next. Okay, so that is here. Now at this point, it could be that odd is now actually pointing at odd next is pointing at null. If odd next is pointing at null, then we have a problem right here, because you see, if odd next was null, So odd next is even next. So we already see that it could not be null at this point, but it could be null at I would say at the point where, let us just check it here. If odd next is null, then what do we do? Then what we should do is, if odd next is null, then even next, which was pointing at the this odd element, should be made to point to null, and and odd next should be pointed to even head. And otherwise this is fine. Even next is considered is basically moved to the next thing, and even is considered moved to this. And if we come to this list over here, we are in good shape. So let's run this code and see if it works. So time limit exceeded. So that means we have a infinite loop in our code, and let's see where that problem could be. So I wonder, because if we did not return here, return head. Okay, so let's run it again. And it has been accepted. Wow. So this was a very good news for us, starting our Wednesday on a very fine note. And I needed this win today because I've been wasting so much time online, and it's easy to get caught up in the and this online. There's so much junk online nowadays that instead of being productive, you end up wasting so much of your time on the junk news, and all these people who are all passionate about the causes that they have. There's always camps in the world. You can always come up with some camp, and you can be part of that camp. And these camps like hate each other. It's all like controversial topics, and it's possible to divide the world between us and them on many criteria. um, I wish the life was as easy as it is in the software world, where we do not have to worry about us versus them. I mean, the singly linked list don't fight with the doubly linked list, saying that hey, or the doubly linked list don't fight with the singly linked list and saying hey, I'm better than you because I have a previous pointer. Whereas you are just freaking bozo with only like next pointer, and people have trouble manipulating you. You don't see them fighting with each other. But if humans were singly and doubly linked list categorized, they would find some cause to fight with each other. They would somehow want to feel superior to others, or some of them will feel inferior to others, and then they just be fighting with each other rest of their lives. So it's good that we are in this objective field, and we do not have to worry about these kind of stupid matters in the world. So now let us try to submit and see if it basically works. And he's saying that we have a problem. He says last executed out input is 1. So I guess it fails if you have a input of 1. So what if, let's just try to do this. Let's see here if we pass, if we have input of 1. Let's see. Okay. So we do have an issue, and the issue is that if you give it a list of 1, we have a problem right here. I can see that actually. Because imagine if you are given a list of only 1 member, even is going to be null here, because head next is going to be null. And if that is the case, if even next equal to null, now even itself is null, and we are basically dereferencing even. Now even here at this point, remember, this is a list of just 1 element, 1 node. That means even is null here. Head next is null, that means even is null. And we are dereferencing, so we have a null pointer dereferencing issue on line 24, and no wonder we are running into this problem. And how we can solve this problem is that we should try to see, we needed a we should have said that while odd or even. Is that a good condition to have? Probably not. It should have been more like, so you see, in order for this whole program to work, you need at least 3 members, right? Otherwise, how are we going to arrange odd and even? If you have only 1, we are done. If you have 2, we are done, right? There's no need to arrange. They're already arranged. If you have 3, then we need to do something about. And we have not taken care of that case. So I would say at this point, if not had, or here, if not even, then also we should have said return had. And here also, because we have to return some pointer, we can either have say had, or if not even, then return had. Let's see now. Okay, so that is accepted too. And so let's try to submit now. All right, awesome. So that did work, and I'm glad that we needed this win this morning. And so basically, I would say the important points to remember in this code is that I hope I made your guys' brains move today. Basically, the idea of these problems is solving these problems on YouTube is not that you look at them as if it is some hot movie or something, but it's more like, hey, if I'm able to make you brainstorm about these problems in your head, and that's because the most of the real software is done in your head, and then when you're already like figured out the algorithm, then you come and start coding. And typing should be the last activity in software engineering. That's what I believe in. So if you take here, I would say what are the gotchas in this problem. One is that make sure that you have at least 2 elements. Make sure that the head is not null, so obviously we move here. Then we make sure that even we have at least 2 elements. So here, let's see here. If the list has only 1 element, return. So this we made sure here. And then we said if while odd or even, if even next is null. Now it could be that it has only 2 elements. Then in this case, if you think about it, it's kind of a no-op, because odd next is already pointing at even, right? So we have, that's fine, it doesn't hurt us. Otherwise, we go ahead and we say we move odd to. So now we have a case here at the line 31 where you know that you have at least 3 members in the list. So that is, this would make odd point as 3, and odd will move to 3. And now we will say if odd next is null, which would indeed be the case, then we would set even next to null. So even would have been pointing at 2, so that's next will be null. And odd next will be pointed to even head, which in this case is also 2. So the list will become 1, 3, 2. and then we'll return head, and otherwise we'll basically continue. And now let's assume that the list has more than three elements, four. So we would not have returned on line 34. We would have gone on line 40, and we would have said even next, which was 2 at this point. We'll be pointing at odds next. So that is 3 is next 4. So that means here we made 2 point at 4, and move even to 4 basically. And that will continue, and everything will be good after at that point. So there you have it. We just solved the Leetcode 328 odd and even list. So when this question was asked to me, one thing that confused me was that I started to look at the odd and even in terms of the value inside the node. So in this case, like int val. Whereas the problem is not even asking you to look inside the node. It's just saying you have a list, and you can just simply that you start from the beginning, and you have nodes which is like odd even, and you basically rearrange it. So it's more like seeing if you understand the pointers, if you understand the, I guess that's what it is trying to test here. But be that as it may be, I will see you guys in the next video. Feel free to write in the comment section if you would like to brainstorm, discuss, or have videos on some other interesting algorithms, interesting problems. And I will see you guys next time. Until then, goodbye. Take care.